Okay, let's have a look at ionic compounds. Ionic compounds are formed by an interaction between a metal atom and a non-metal atom. Now there are some exceptions to this, but we'll talk about those shortly. Now they're named ionic compounds because the elements bond from ions. So we have an example. We've got sodium and we've got chlorine. Sodium typically loses one electron quite readily to become a positively charged sodium ion. Chlorine, on the other hand, likes to gain one electron, so that becomes a negatively charged ion. So metals lose electrons to become positively charged. Non-metals gain electrons to become negatively charged. Now if we have a sodium ion and a chlorine or a chloride ion together, the positive and negative charges will be attracted. So we will form what's called an ionic bond between the two. Now we must, in our compound here, we've shown that we've got one positive and one negative. So overall this compound has what we call a zero charge. Now to complicate matters, and it's an exception to this rule, we can actually form radical ions as well. And this is where we've got a group of non-metal atoms that group together to form what's called a radical ion. So we've got sulfur and 4 oxygen atoms bond together in that radical, and overall they have a -2 charge. Nitrogen can bond with 3 oxygens, and overall it will have a -1 charge. Hydroxide, an oxygen plus a hydrogen, also has a -1 charge. Carbon with 3 oxygens can have a -2 charge. And then we've got a nitrogen with 4 hydrogens, and unlike the previous examples, this has a positive charge. This one's called ammonium. So in the same way that we can put our molecule together there in an ionic bond, we can do exactly the same with a metal bonding with a radical. So we can get sodium bonding with our nitrate to become sodium nitrate. But we can also substitute our metal, which is positively charged, that ion. We can substitute it for ammonium, so we can get something like ammonium bonding to another non-metal, chlorine, to give us ammonium chloride. So how does the ionic bond work? Well, an ionic bond forms between oppositely charged ions. So if we have a sodium ion, borrowing from our example on the previous slide, bonding with a chlorine ion, we form a bond between the two. So there's an attraction between the positive and the negative here, and we form that ionic bond. So once again, we'll notice that there is 0 charge on this particular molecule here. The positive cancels out the negative. Now we can also get calcium, which has got an ionic charge of +2, bonding with chlorine. But in this case, we have one positive going with one chlorine and one positive going with another chlorine. So in this case, we form 2 bonds. And once again, as we form our product here, it will have 0 charge. So we form calcium chloride with 1 atom of calcium going with 2 atoms of chlorine. Now our last example, we have a radical. It's a sulfate radical. And we have a copper ion that's got 2 positive charges. The 2 positives will be attracted to the 2 negatives. So we actually form 2 bonds in the system. So we form the molecule copper sulfate. And once again, because our positives neutralise our negatives, we have 0 charge on the copper sulfate. So what are our properties of ionic compounds? Firstly, they don't form individual molecules. So we don't see an individual molecule of sodium chloride. Instead, we see giant lattice structures, which we view as crystals. So we have a sodium ion, and close to it will be a chlorine ion, then another sodium ion, then a chlorine ion, sodium, chlorine, and we can get this in 1 dimension, 2 dimensions, or 3 dimensions. And this forms what's called our giant lattice structure. Now, in general, ionic compounds also dissolve in water. That's in general. Not all of them do, and some are only very slightly soluble. However, we're making a generalisation. So when we put sodium chloride into water, the positive charge of the sodium is attracted to the slight negative charges in the oxygen on the water, so the water molecules pull this sodium apart from the chlorine. And in a similar way, the negative charge on the chlorine is attracted to the slight positive charge in the hydrogen, so the hydrogens in the water pull the chlorine apart from the sodium as well. So as we add more water to the sodium chloride, it'll pull these two, or it'll pull the sodiums and the chlorines apart from each other, and eventually we won't see any table salt in the water. Instead, the sodium and chlorine will be dissolved in that water. And our third property of ionic compounds is that when they're placed in solution, they conduct electricity. And the reason they do this is because we've got lots of positives and negative charges in that solution to allow the electrons to flow through it. And if we have a flow of electrons, it means that we can allow electricity to flow through that solution.